Hi, everyone. Welcome to our webinar today. Glad you could be with us. My name is Wayne Eckerson, and we are here to talk about how to do data ops with Snowflake. We're going to look at tools, one tool in particular that works very well with Snowflake and helps you implement data ops principles, and some general rules of the road for how to implement data ops. So just very quickly to give you a little background, we're a research consulting and education firm based here in Boston. We work with companies around the world to help them implement modern data architectures and data strategies and data governance programs, among other things. But the focus of our topic today is a lineup of speakers that we have here. You can see myself, Justin Mullen, CEO of DataOps.live. After I give a few words about to set the stage for data ops and provide some context, Justin will then talk about DataOps.live, one of our new data ops vendors in the space. And then after that, we will drill down and have a conversation between me, Guy, and Sam, who will be showing you the tool and some of the cool features that it supports. So with that, let me give you a little background on data ops if you're new to the space. Essentially, data ops stands for data operations. It's a play off the term DevOps, which has been around in the software engineering space for nearly 20 years. And the goal of data ops, like DevOps, is to optimize the development and execution of code, in this case, data code or data plus programming code, the combination of which we call data pipelines. And if you take a 100,000 foot view of data ops, it's really about helping data development teams move from an artisanal development process to an industrial scale development process. It's got a lot of different dimensions. It's a big space. There's a lot of data ops that involves agile capabilities, DevOps for sure. We'll see a lot of that today. Total quality management and lean principles, all that mixed together tends to form data ops. And every organization that implements data ops tends to do it in a slightly different way, emphasizing one of these disciplines perhaps more than the others. So why implement data ops? Well, a lot of development shops in the data and analytics space are facing growing demand for data. And the data pipelines they're building are increasingly complex, comprised of multiple tools from different vendors, pulling data from multiple different sources and to support multiple targets, both individual users and applications. At the same time, there are not enough skilled people to build and manage and monitor these pipelines, which means that the data team has quickly become a bottleneck. And from a business perspective, that's not really acceptable. The solutions are slow to deliver. They often contain too many defects. The cost of developing and delivering them from a business perspective is too high. And this results in very unhappy customers. So there's got to be a better way. And that's what data ops promises to do. It promises to speed your cycle times and give you fewer defects at the same time, which is kind of interesting. We can go faster and yet do it with higher quality. We make reuse of code, and that gives us together more efficiency and agility. And our development teams have greater capacity to build more in less time. And from a business perspective, this achieves the holy grail of faster, better, cheaper. And this is what customers really want. So I do think, and we've been studying data ops for 2 years here at Eckerson Group, it really is something that's been missing. It's the missing piece in the equation for how to do data analytics. We've always been a bottleneck, and now with data ops, which is a combination of people, process, and technology, we can achieve that holy grail of faster, better, cheaper, and happier customers. So this is a framework we put together a while ago to explain data ops, where it fits into the data management space. The light blue, obviously, is the data pipeline, where we're going from source data through ingestion, engineering, visualization, and where and then at the end, it's consumed by various business users or applications. Below that pipeline, in that semicircle, are all the data management and analytics technologies that we've come to know and love over the last 30 years or so. And the missing piece has been what's above, and that's all the DataOps functionality that vendors like DataOps.live are bringing to the table. The tools that have existed in the software engineering space, but are now being tailored to data development, because in software engineering, all you're managing is code. But in our space, you're managing code plus data. It adds a level of complexity that's not actually in the software space alone. So these different parts of DataOps consist of continuous integration, continuous delivery, sometimes known as CICD, when you put those two together. That enables development teams, data development teams to work as a team to build things in parallel. Orchestration, workflow, and scheduling. So once a job is built, it's kicked off and all the different tools and jobs are executed automatically. And then perhaps most importantly, continuous testing, where we are building tests as we develop code and then as we run it in production. And sitting in the middle of all that DataOps functionality is a code repository, typically GitHub, configuration repository, and other things as well. So I mentioned that we've done a lot of research on this topic at Eckerson Group. Our most recent report you see here, DataOps Deep Dive, where we took a look at 4 different DataOps products in the space. We showed where they fit according to that framework I just showed you. And these are the 4 that we profiled in that report. There are more, obviously, than this. And today we are taking a look at DataOps.live, which is a very new company, but has an exciting product, and it's geared largely today to Snowflake. So to help you better understand what DataOps.live brings to the table, I'd like to turn this over to Justin Mullen, the CEO.
Thanks, Wayne, for the introduction. I think we've all seen over the years that you've been, one of the leading analysts in terms of analyzing the whole space. So a lot of great content that we've built on in the past. Just to, give you a quick summary of how long have we been around. I guess we're quite a new organization in terms of the branding and DataOps.live. We're months old, but we've been years in the making, and so we've been formed out of a company which is called Datalytics, which many of you might have heard of in the past, a long-term partner of Snowflake and Talent and various other data platforms. And we've been part of that business was not only a services business, but also a software development business that was being incubated inside Datalytics for a number of years. And over that time, we started the whole development of the DataOps platform way back in 2018. We do a lot of work with time series data and had the pleasure of working with Thierry and Benoit from Snowflake around some of that work. But really, the whole concept around DataOps and the whole philosophy for DataOps started mid-2019 and continued on then through 2020 as we launched the platform. We launched it as the first DataOps platform on Snowflake in the middle of 2020. Guy, one of the great data superheroes, our CTO, will be talking later, in Snowflake. But where DataOps came from is in late 2020. Datalytics was sold to a company called Emphasis, which is a global technology provider, one of the top worldwide. And out of that, we took the technology elements and the product that we've been developing over the previous 2 years and brought it out into DataOps.live as a new company. So months old in actual terms, but years old in terms of the growth. And I think just to set some context around that, where we're formed out of and where we came from is that area of that philosophy that I mentioned to you before. From our perspective, DataOps is not a technology. It's not one technology. It's a discipline and it's a way of thinking. And we really started evolving that very, very early on in 2019. And it was work with myself and Guy and Ken Graziano from Snowflake, who's the chief technical evangelist over there, Wayne and the support and all of the work that he's been doing around DataOps over the years, and Mike Ferguson over in the UK really brought together this philosophy called True DataOps. And please feel free, go sign up, join the movement. This is technology agnostic, and this is about the way in which data and data platforms should be built in the future. And we're taking a lot of the learnings from that and putting that into the DataOps for Dummies book, which is due out next month. But very founded in philosophy. So just one thing to note. And there's quite strong background to that. You'll see if you go to truedataops.org, a lot of these core pillars or these core principles of DataOps, the whole focus around ELT and just bringing data in as it is, and then delivering all of your processing and all your change and all your transformation within the data platform, within the data cloud. Some of the other areas that are particularly specialist and quite nuanced to data are around environment management. How do we manage the environment that's supporting and holding our data in the same time that we're managing the code base that's driving it? So feature branching code and feature branching data warehouses and data platforms at the same time. So we'll talk a little bit about some of that during the session today. But just to finish in terms of what it is, I suppose, to answer your question, Wayne, what it is it's a data platform that's built on top of Snowflake, primarily on Snowflake now, because Snowflake has all of the correct and prerequisite features that we believe in true DataOps that you need to have to deliver the true essence of agile and DevOps in data. If you think of Snowflake holding a lot of the data that you'll want to protect and govern, you'll want to interact with that, with all of the usual suspects, the great solutions out there, Stitch, Informatica, Talent, Fivetran, and even holding, open source solutions like DBT and Python and various others to drive and manipulate data in and around the Snowflake platform. Where DataOps fits is at this top layer, this layer we call the orchestration layer. And so that's really where we fit, and that's what we'll be talking to you a little bit more about today, how we manage and orchestrate through all of these tools directly into Snowflake and beyond Snowflake into its data sharing and in the ecosystem of the data cloud. So really, that's a bit of the background, Wayne. We've got some great customers. Anyone can go and have a look at the website. But yep, hopefully that answers the question.
Yeah, thanks, Justin. That's terrific. Now we would like to bring in Guy and Sam to have a little discussion about DataOps.live functionality. Okay, so we obviously have done a lot of research on DataOps and a variety of tools in the space, including yours. One question I have is about how your product can really support large teams of developers who can work together to build code without interfering with each other. That to me seems like a key part of DataOps to scaling that up. So maybe you could address first and foremost how you do and support team-based development.
Okay. The challenge here, Wayne, is really with traditional TL technologies to handle a requirement, particularly an urgent business requirement, let's say, for some new work to be done in the data space. A good approach for an urgent requirement is to throw more resources, more engineers at the problem. But with a lot of traditional ETL tools, if you're doing work on the same piece of code, the same job, the same model, the same flow, whatever it is, normally only one engineer can lock that at any given time. So you'll find that the first engineer has to go in, do their work. They've got the job locked to them. No one else can do anything in there. They might be able to open it read only, but they can't work on it up to the point that first engineer has finished and done their local testing. Then the second engineer can pick it up once it's been unlocked, and so on. So it's a very sequential process. So you really lose the benefit quite often of actually throwing more resources at the problem. That can be contrasted with the DataOps style of approach, which allows each developer, each engineer to separately pull the code and work in parallel. So they're working on their own environments, isolated from each other. They can work in parallel to develop whatever new features are urgently required for this business requirements. They can then push their code back and have that merged together by the system. And it's only really in the rare cases where there are conflicts, where two engineers have overwritten the same line of code, there might have to be a conflict. But otherwise, the code gets merged together. That also gives an opportunity for a peer review, so you get quality assurance built in. And the work is often done a lot quicker than with a sequential process.
So that functionality is usually supported by what we call CICD, right? Continuous integration, continuous development, which your tool supports.
Absolutely, it's founded on a CICD style of flow. Here's the view from an actual repository itself. Now it's a bit technical. This is a timeline going upwards. If you can visualize it, this is the point where each of the engineers started work. So actually, in this scenario, we've got 4 different engineers. They all take a cut of the code at this point. Now the first engineer is working on this green line. They do their work. They commit it back in. At the same time, engineer 2 is also working on a different feature. They're adding another, in this case, it's a customer 360 model that they're working on, and they're adding a different field. And again, user 3 working in parallel again. So they're all working at the same time, committing the code back and merging that in to the main code base. So then their changes can all be tested with integration testing into the single code base that they've got.
So they're all working on the same lines of code without interfering and stepping on each other.
Absolutely. There's a chance that there'll be a conflict, and in fact, in this demonstration, we can show that because we have a scenario here where 2 of the engineers actually have overwritten the same line of code. This is the merge request. This is where we can see engineer 4 put in to merge their code. There are merge conflicts in here, so they can't just merge it straight away. However, the engineer themselves or a colleague can go in here, and this highlights the lines that are conflicting. So we can see very quickly, we've got one line here that's conflicting with another line. They can just decide, do I use my change or do I use the other person's change? And likewise, there's another one down here. They can make the same decision. And if it's not quite as clean cut in those rare occasions, there's an inline editor. They can edit it inline. So they're not having to pull the code back and work on it separately. They can fix it very quickly in this interface. Once these issues are resolved, they can go back, hit merge, and that code goes straight through into the main code base.
Yeah, so now a big part of DataOps is testing, Sam, right? A lot of companies are adopting a test-first development approach. So how does that fit into what you're showing here?
That's a good point. I mean, because we can see from the way the engineers have worked, if I go into the code that was raised by the first engineer, they've actually made 2 separate commits to the code. That's 2 separate pieces of work they've done. The first piece of work they've done is purely testing. And what they've done here, their requirement was to add a total of all the sales tax for all the orders for a customer. What the first thing they've done is they've taken the field name that they've been given by the business team, who've said that's the field name that's got the tax in it. They've taken that and they've put a test around it to make sure that actually does contain data. Because as we all know, quite often these systems are so complicated that there might be a dozen different fields and it could be any one of them, and the documentation might not match. So we put a test on at the source to make sure that before we start doing any modeling work, any work to add that field to our model that's going to go through to our business intelligence and everything, we put a test on it. So first thing we do, put a test on. This engineer then would have run this test to make sure before they do any work, they know that field is going to have data in it. Now there's more testing they could have put on that. They could have tested for different values, different style of data, all that sort of thing. This is start with the basics, 80-20 rule. You catch most problems with we're looking for an empty field. Once they've done that, is they can put in the code change to actually add the field in. So the actual lines of code, because there's a comma added, it looks like more, but actually this is just 2 lines of code they've added. That's all they needed for this change. But again, they put another test in, and this test is then on the way out. So they put a test to make sure that the calculations they've done, they've not dropped any data, they've not left anything set to 0. And again, more tests could be put in here in a real world example to actually have different aspects of this feature being tested. So all these tests will be added in, and then these tests, if we go back to the request itself, all these tests will be run. So 57 total tests. There would have been 55 when this engineer picked it up. They've added 2 more. These tests are all broken down into categories. So anytime the code base is run, it adds every test, and every engineer that works on it adds more tests. So this total number of tests goes up and up and up, such that engineers are not just testing the new features they add in, they're also making sure they've not broken any of the features that are already in the code base.
So are those tests also run once you put this code in production?
Absolutely, yeah. So these tests stay with the code the whole life cycle. So when we deploy to a dev environment, to a QA environment, to pre-production, to production, these tests always get run. And any good production release workflow will not allow code to go in if any of these tests don't pass.
So rule of thumb, how many tests should you have per block of code? Or is there any rule of thumb in the industry for this?
Different people have different views on this. I mean, it's all about test coverage. It's about making sure as much of the code as possible has one or more tests that cover it. So it might be a big block of code that only needs one test. It might be a small piece of code actually needs a dozen or more different tests to cover it. So it really depends on the code. But we look at coverage. We say, does this particular bit of code have any tests? And if it doesn't, we need to ask why and make sure, if we can, we put some tests on it.
Excellent. Well, that was a very good look at those team-based capabilities. So why don't we turn now to Guy? I think, Guy, you're going to show us some orchestration capabilities of the product, right?
Yeah, absolutely.
And the reason is because there's so many tools that companies have. I think Justin showed a whole list of data integration tools that any DataOps tool worth its salt, it's got to be able to work with all of those, right?
Absolutely. So if we go and look at one of our demo projects here, and we'll go and look at a production pipeline. It's one of the first questions that we get asked by a lot of people is, can you support all of our tools? And what we've seen historically is people have tried to reduce the tool set as much as possible. People have tried to move to a situation where they've got the smallest number of tools. How do I rationalize my tools together? How do I try and get down to just one or two tools? The problem with that is the actual data ecosystem is going the other way. More and more tools are coming along, and each of those tools are very, very good at what they do. So trying to standardize on one tool actually means that you very often you're making a lot of compromises. But really, the big challenge of running lots of tools is the operational challenge. How do I make them run together? How do I monitor them, schedule them all in one place? So by taking a DataOps approach and putting a single pipeline on top of those tools, you can now use a true best of breed. For example, I've got data in Salesforce that I want to take out and dump in Snowflake, then I'm going to use something like Stitch. If I've got some on-prem relational databases, I'm going to use something like Talend or Talend Cloud. If I've got a different system, I might be using Matillion or Fivetran. I may even have some systems I've built myself. A surprising number of customers come to us and say, yeah, we've got a lot of standard off-the-shelf tools, but we've also got something that we built for our own purposes. And it's really important. It does something very specific that we need. Can you orchestrate that too? So from our perspective, as Justin said, the first and foremost responsibility of a DataOps pipeline is orchestration. And that means supporting pretty much every technology out there in the data ecosystem, but also being extensible to technologies that people have built themselves. The other part of this is not just being able to kind of integrate with these systems, but to be able to schedule everything happening together. You can imagine this is a bit of a choreography. That in a pipeline like this, you've got so many things that need to happen in certain orders. I need to ingest this data before I can do that incremental work. I can't do testing until the data is loaded. I can't do further testing, or I can't do slowly change in dimensions until 3 or 4 sources have all been loaded together. So a big part of building these pipelines isn't just being able to kick off arbitrary pieces of work, but it's being able to stitch them all together to say what things need to happen in what order, what things can't happen till other things are finished, and also other things are finished successfully. If I know I've got a major ingestion job that fails, there's absolutely no point in me going downstream trying to do some transformations or some modeling or some testing, because I know that the data for yesterday I should have loaded has just failed. So building a pipeline that says all the right things happen in the right order after the right things, and assuming those things have been successful, is a key part of a DataOps pipeline.
Excellent. Now, I know at this point, our audience probably has a lot of questions, so feel free to ask us any questions. Just go to the Q&A button at the bottom of your screen, click that and ask a question, and we'll be taking those in the last 10 minutes of this session. So Guy, just drilling down a little bit more, how does this work to support different data environments like dev, test, prod, and even different platforms on-premise in the cloud, different databases and things like that?
Okay, so let me just switch over and show, this is essentially the problem we're trying to deal with. My background before I came to the data world was software, so the concept of deploying to different environments is pretty second nature to me. But this is the problem people are trying to solve. Sam showed some branches where an individual engineer created their own branch. We saw them fork off. They went away and did some work, and they merged some of that work back into development. And obviously you've got lots of these happening. In some cases, those things don't work. In some cases, someone checks some code into development and it doesn't work, so they've got to revert that back out. Some of the features in development are ready for QA testing. Maybe some of the QA testing passes, some of it fails, maybe it all passes, and we want to put everything to production. But environment management is really about, how do we manage all of these environments, and also how do we manage the movement of code between the environments. And the real trick here is to acknowledge that treating these as independent sources of truth and trying to rationalize them as isolated things is never going to work. The only way that you can make this work in the data ops world is the same way that we made this work in the software world, is by moving the source of truth out of those individual databases or out of those individual instances into a single source of truth, which is pretty much universally a Git repository. And then those data ops pipelines become your deployment tool. So you deploy from different branches and you link those branches to different environments. In this case, there'd be different databases in Snowflake. So what I looked at before was the master branch that was populating the production database, but I might have a long-lived QA branch and a long-lived dev branch, which are populating similarly named databases. But in Sam's environment, when his engineer was going off with a feature branch, that engineer can deploy their entire branch, which will create a completely standalone, completely isolated copy of the entire database using Snowflake zero copy clone, which is an incredibly important feature for enabling DevOps. If we go back and look at how that looks in the pipeline, in a production or in a master pipeline like this, I'm actually creating or making sure a database exists. I'm doing all of my ingestion. Whereas if I go back and look at, for example, a feature branch or a development pipeline, so here's a feature branch pipeline here, we can see it works a little bit differently. Rather than creating a new database, we've got the step which does clone, mask, and grant. So we're using Snowflake zero copy clone to create a very fast, essentially zero cost copy of my production data. But then all of the other pieces of work, all that modeling that Sam's engineers were doing, adding new fields and things, all get executed on top of that. So I've got a complete sandbox that I'm able to do my development in. And this reduces development costs by 50%, often a lot more than that. But because this is generating ultimately on just another Snowflake database, it also improves agility, because as those engineers are developing those features, the stakeholders can be looking at them. The stakeholders can be treating them just like any other Snowflake database. They can be pointing their reporting tools at them. So a big part of agility is not just how quickly can I do my work, but it's can I interact with my stakeholders to review my work and make sure it's what they actually want.
Hey, Guy, just to be clear, that zero copy clone feature of Snowflake, which is making all this much more efficient, that's not replicating or creating a new copy of the data, physical copy of the data.
Correct. You can copy, and we're doing this to customers who are copying many terabytes worth of data. It's a very, very clever and efficient feature inside Snowflake that creates, essentially, it looks like a complete copy of the data, but actually it duplicates nothing, but it still allows you to update it. And when you do make updates or changes to it, it just stores the updates and changes, but it doesn't replicate any of the original data. So it means that you can do a clone step in a few seconds, keep this branch and keep this environment for an hour. In the case of probably Sam's developer, then more than an hour, and then wipe it out. And it probably costs you a few cents. So I think from an environment management perspective, that's probably it. The key part of this is that these pipelines are internally environment aware. So you don't have to go in and build a different pipeline for dev and QA and prod. You build one pipeline, and the DataOps technology adapts that pipeline to the different branches it's running in.
Now, some people, when they think of environment management, they're also thinking of the underlying platform. So are all these pipelines and dev, test, and production environments, are those portable across different platforms, say in the cloud?
So they're portable across any Snowflake tenancy, and you can repoint this to a different Snowflake tenant. In fact, one of the nice features about DataOps is it can operate across many Snowflake tenants at once. We've got one customer who's orchestrating in a single pipeline just over 60 different Snowflake tenants in different parts of the world, in different regions, including replication and things like that. So the concept of a DataOps pipeline transcends any individual cloud provider, any individual region, any individual Snowflake tenant. It can operate against all of those and potentially all of those simultaneously. But as Justin mentioned at the beginning, today we only support Snowflake because we believe Snowflake is the only cloud data platform that has the requisite set of features and capabilities to enable true DataOps.
Okay. Well, why don't we move on? I know from doing our research that you have done some fairly unique work around IoT data, providing some high levels of compression and then allowing organizations to pull that into Snowflake and merge it with their operational data. Do you want to give us a little preview on that?
Yeah, so I mean, we focused on IoT data really because it represents such a big problem. There's lots of different terms for IoT data depending on what industry you're in, but it's just about the fastest growing data set in the world after video. It's the second biggest data set in the world after video, and it represents a challenge for a remarkably large number of enterprises. So that the use cases that we are talking to is, the traditional IT data, the ERP, CRM, sales, customer databases, we all get those and we all understand how those work and we understand the use cases that they support. What you will find in a large number of organizations is they have their operational systems. These are their factory systems, their production line systems, their engine monitoring systems, whatever they are. And there's a set of use cases and they have specific monitoring tools. They're usually called historians, and those support a specific set of use cases as well. The problem is this: there's a set of use cases that people want to answer that cannot be met without getting data from and joining data across both these systems. And historically, these have been very, very separate. So this is where you may hear the term used, kind of IT-OT convergence. This is the term a lot of the analyst firms are using, but it's basically bringing together our traditional IT big data with all of our operational data, our time series data, so that we can execute all these use cases. And obviously, if we have that in Snowflake, now we're talking about just simple joins. The challenge with that is those data sets are enormous, very often, usually in the petabyte range, sometimes even in the exabyte range. So even inside Snowflake, pulling in petabytes of data and joining that onto other tables is challenging. But most of these use cases don't need perfect data. So the technology that we built is about how do we reduce the data volumes massively with only a tiny reduction in accuracy. And the typical figures we see is we can get a 99% accurate picture of the data for 1% of the overall data volume, so 100 to 1 data reduction. So if we kind of apply this concept to time series data, the two ways that people reduce time series data and have done for the last 25, 30 years is either with sampling or with averaging. And we know what sampling looks like. Sampling is a very random approach. There's no guarantees of what you're going to see. Averaging is a little bit more deterministic, but it still loses all of the peaks and troughs and the interesting parts of the data, and it still delivers a very low and not guaranteed level of accuracy. These are looking at graphs at 100 to 1. If we take our IoT compression technology at the same 100 to 1 data reduction, this is what it gives us: a far, far high level of accuracy. In this case, it's about 99% or over 99%. But more importantly than that, it's a guaranteed level of accuracy. So if I'm making a business decision based on some IoT data joined together with some traditional big data, I don't want to make a business decision based on data that I can't guarantee the accuracy of. I'd like to make it against 100% accurate data. But if that's a petabyte's worth, I'm probably not going to wait the 1 or 2 days it's going to need to answer that question. But if I can answer that question at 99% accuracy in a few minutes or even a few seconds, for the vast majority of business use cases, that is enough. So we then orchestrate this technology inside our DataOps platform. So if I go and look at, for example, one of our demonstration projects for this, and go and look at a historical pipeline, this is actually taking data, time series data that's been loaded into Snowflake, and it's then processing it through the Gallium technology. So this is the product name for our IoT data compression. So we can see it actually running through these different files, running through these different sets of data, loading that data back into Snowflake. So we see it being re-ingested here. We're doing a bit of modeling on it, doing a bit of testing on it, and ultimately we're generating plots that look something like this, which is similar to the ones we saw in the slide. And I don't know how well you can see it on Zoom. There is a slight difference between the red line and the green line, but you're talking about a 1 or 2 pixel difference. So this is a 99% accurate view of the data in the green line, but at 1% or less of the original data volume, which means that I can process it hundreds and hundreds of times faster than I would have been able to with the original data set. And so for us, this ability to bring massive amounts of IoT data into Snowflake, to run it and join it alongside our traditional big data, is the technology for unlocking IT-OT convergence.
So it sounds like a silver bullet in some respects, but you don't throw away the details, right? So if someone does need to drill into those detailed records that are not in the compressed file, you can still get at them, right?
Absolutely. So, Snowflake's model, by separating storage and compute, makes storage costs very, very low. So traditionally, we would have said, well, keep the 99% accurate data and throw away the remaining 1% because it's going to cost you a lot. With Snowflake, you don't really need to do that. We can store all of it, but what we do is organize it in such a way within Snowflake so that you can query for the level of accuracy that you need for your question. So if I want to answer a question about 100,000 sensors all over the world for the last 15 years, probably even 95% accuracy is plenty for that. So I can ask a question that would have otherwise used many petabytes worth of data, but I can get a 95, 98% accurate answer very, very quickly. In exploring that data, I might realize that actually what I want to look at is this one sensor in this one part of the world for a 2-week period, sometime back in 2015. And now I can drill right down into that, and I can increase the level of accuracy, potentially all the way back up to 100%. So I can answer very broad questions incredibly quickly with a small reduction in accuracy. But when I really want to drill into the data and answer something very specific, I can go all the way back to 100%.
Yeah, that's fantastic. You know, it's impressive, the ability to combine this IoT data with your operational data. I don't know many companies that have been brave enough to undertake that. So this provides a promise that this can actually work. So, Guy, we've covered a lot in a very short period of time. In fact, probably faster than we even thought we would. But we've covered team-based development. We've covered CICD, how to avoid conflicts when multiple developers are working on the same code. We've looked at some testing, talked about testing and test-driven development. We've looked at orchestration and how do you create jobs across multiple different tools and execute them in the proper order. Probably the one thing we didn't talk about was monitoring, but I think we'll have time to address that. But before we turn this over to Q&A, and I do encourage our audience to use the Q&A button to submit any questions. Looks like we have a good number already. What's coming down the road? You guys seem to be full of new surprises. What do you have up your sleeve that you can share?
So I think the biggest thing that we've been working on, I'd say probably the last year for us has been focused on managing what I would call the flow and lineage of data through the system. Because that's the first thing that everybody jumps to. How do I get my data in? How do I transform it? How do I test it? But when you look at something like Snowflake and you look at the actual objects inside Snowflake, Snowflake today has, I think, 30 different types of objects. And every one of those type of object has another layer in terms of the grants and permissions. So really, in many ways, we've got sort of 60 different things to manage, 30 types of objects, and then the permissions and grants around those 30 types of objects. When we look at the management of the data or the data carrying object, really we're looking at 3 or 4 of these and the associated grants. So they're the ones that everybody jumps to, and they're the ones everyone wants to focus on, and they're absolutely critical pieces. But the question that we've been wrestling with for the last 6 months is, what about the other 27? How do we deal with file formats and network policies and security integrations and stages and virtual warehouses and things like that? How do we lifecycle all of these things? Because a DataOps pipeline that just deals with my data but still has me logging into a workbench to create or update a warehouse really isn't a very viable approach. When people want to automate, they want to automate everything. When I run a pipeline, it should be taking care of everything, not just the objects in the system that carry data. So what we've been looking at is how we kind of separate these two out. We've got the data carrying objects pretty well managed now in our modeling and transformation engine. Sam just gave a few very kind of early hints to this. But what we've been looking at is this life cycle management for everything else. And there are really 2 approaches to this. Everything falls into one of 2 buckets, kind of an imperative approach, and there's various sort of subdivisions of this, versus a declarative approach. And the best way to understand the difference is if you think about directions. In a particular place, I want to get to 221p Baker Street, and someone can give me a set of very, very clear, explicit instructions. But I've got to do all of the work here. It's a very clear set of steps to follow. A declarative approach simply describes the outcome I want. So from my current location, I want to get to 221b Baker Street. And it takes a much smarter system to manage that. And of course, that much smarter system is a sat nav or a Google Maps or something similar. But ultimately, what they're implementing is what we call a declarative compiler. They're taking that outcome. Ultimately, I can't just describe. I can't look at this outcome and execute it. I still need to know where to turn and how far to go. But that's generated at runtime. My definition is declarative, where I want to be, and the steps to achieve that are generated by a declarative compiler. In this case, a set of directions to get to my house from 221b Baker Street. If we take that into the database world, SQL is a completely imperative language. You can tell that because it starts with verbs: create, alter, drop, grant, revoke. They're all verbs, and that means that what we're giving here is instructions. We are telling, in this case, Snowflake, to create something, to alter something, to drop something. And we have to do a lot of the work for that. And in particular, these create a lot of problems when you're trying to build repeatable pipelines, because how do I do a repeatable alter table add column statement? And there's lots of ways that people have tried to get this working over the years, and we've got a set of, if you're interested in this, we've got a set of blog posts on our website that describe all of the different approaches to this over the years and the challenges with them. And there are some good approaches that worked in database for a long time, but the advanced features in Snowflake, like time travel and zero copy clone, really break the premises that all those systems are based on. Ultimately, what we want is a declarative approach. We just want to say, my table should look like this, or my stage should look like this. And every time I run my pipeline, we want a declarative compiler that looks at Snowflake, looks at what the world is as it stands at the moment, looks at my definition of what the world should look like, compares the two, and based on that, generates a set of instructions which it injects into Snowflake to make the world as it is look like the world as I want it to be. And it's the job of the declarative compiler in the pipeline to worry about that. So essentially, it means I can just describe my entire Snowflake infrastructure, all 27 remaining objects, as a set of, for example, YAML configuration files, and I run the pipeline. I don't care how much of that is there or not, whether it's old configuration, how much of it needs to be updated. I just throw it into the pipeline and let the pipeline take care of it. And this is a much, much more robust approach than any of the imperative approaches. It can handle tampering, people going to make manual changes to the system, which happens an alarming amount. It works with all the advanced Snowflake features. It's far simpler for users to implement. Users don't have to worry about writing their own auto table statements or auto stage statements. They just put in some configurations about what they want and let the system take care of it. So, and it also works very well with our environment management. So we can create different versions of all of these objects in the different environments that we operate in. So this for us is kind of the next big thing in DataOps. Is we've pretty much cracked the data carrying objects and how we move and version those through the system. What we're now trying to crack and are close to having our first release of is how we manage the other 27 objects out of Snowflake. And this fits very well, I think, with the direction Snowflake is heading. If you look at Snowpark, for example, recently announced by Snowflake Summit, it's pretty clear the direction Snowflake are going. They are turning Snowflake into a programmable data cloud, and that's absolutely the future. And we think DataOps is going to be the approach and the technology that's going to power that programmable data cloud.
Wow, that's not too shabby a vision for effectively a one-year-old company. We know you're older than 1 year, essentially, but that's amazing. I mean, in many ways, that speaks to what DataOps is really all about. It's not just about developing and executing data pipelines. It's about automating them. And that sometimes gets lost in the shuffle, but this declarative approach, I think, will help achieve that holy grail, right?
Yeah, and it's and a big part of what we're doing is just trying to remove complexity. We've worked with so many customers that have done bits and pieces of this themselves, and I've seen the most frankly, incredibly ingenious solutions that people have come up with to try and solve this problem of, how do I write and decide when to run these sort of imperative statements as part of repeatable pipelines? But ultimately, it's a problem that users shouldn't have to solve. They're having to solve the wrong problem. Ultimately, if we can build this declarative compiler, this is something that people will just not have to think about anymore. And it will become, if you've got any background in things like the infrastructure as code movement and using tools like Terraform, this is what we've done for a decade or more. We just create a configuration file that describes what we want, and we run a command, and it just happens. And it doesn't matter whether the system is completely empty or it's partially there or it's got an old version. We just completely use the tools that will take our definition of what we want the final state to look like, and it will do everything required to get there.
You don't have to code the outcome that you want in the declarative approach, right? You're just configuring
you're just giving the configuration of what you want the final state to look like, and you let the system take care of everything else.
Yeah, and that configuration is something that happens inside your tool.
And it's so important inside Snowflake in particular, more so than probably any other database or data platform historically, because so many objects in Snowflake carry state. The traditional approach that a lot of people have used to get around this is, oh, well, I'll just recreate the object every time, create or replace stage. Well, that's brilliant, but stage, and that solves your configuration problem, but stages are full of state. Stages have all sorts of state, and every time you replace it, you lose that state. So a lot of the advanced features inside Snowflake rely on these objects being stateful, and therefore you can't just wipe them out with a create or replace every time you want to change a configuration parameter.
Terrific. All right, so that concludes our formal part of the webinar, and now we're going to turn to audience Q&A with the infinity loop as the background. Unless Guy or Justin, there was something else that you wanted to say before we jumped into Q&A?
No, I think we've got a lot of questions that I can see in there, so I think we should just jump straight into that and start to pick some of these off. So
Yeah, let me ask the first question, Justin. I'll let you pick the second one.
Yeah. Okay.
We can alternate back and forth. So what if I need to orchestrate something that your platform doesn't support, something that customers built themselves, for instance?
So I can pick that one up. When we saw all of those lozenges in the pipeline, and just switch over, actually every single one of these lozenges, when you actually look at what's happening behind the scenes, is an instantiation of a Docker container. So everything that we build, all the integrations with all the different technologies that we've talked about, our own technologies, integration with Snowflake, integration with all of the other tools in the data ecosystem, we build all of those as Docker images. And we have generic Docker images. So if you want to run Python 2 or Python 3 or Scala or R or Node.js or any of those, we've got Docker images pre-configured within DataOps to do that. But ultimately, if you want to do something that we've never even heard of, we had a customer about 3 months ago said, we've got a binary. It was written by someone who's left the company. They took the source code with them. All we have is this compiled binary. We use it and it's important. It does some valuable work with it for us, but we have no other option than to run this binary. How do we do that in DataOps pipeline? So we said, right, here's a couple of lines of configuration to build that into a Docker container, and they're then able to orchestrate that. So we can support anything that can be run inside a Docker container, whether it's built by us, whether it's built by a customer, it's built by a partner, or whether it's one of the 100,000 plus images on Docker Hub, which are freely available.
So when you orchestrate, you're really orchestrating Docker containers.
Yeah, and that gives us, isolation, that gives us the version control, and that gives us the ability to do essentially anything. If it's possible to do in a Docker container, it's possible to do in a DataOps pipeline.
Excellent. Justin, you got a favorite?
Yeah, I got a great one here. So it's a well-written one. So guy, it's let me read this out. From an operational view, how do you make sure that each step in the pipeline really work? E.g., steps from on-premise to Snowflake. How do you monitor the whole process? E.g., if one step failed, e.g., due to networking issue, will the job reprocess from where it failed?
Yeah, well, this lets us get back into that monitoring issue, which is the one facet we didn't talk about. Okay.
Yeah. So every one of these jobs will have definitions inside it that say, what does success look like? And if a job doesn't meet those criteria, the job will fail. By default, any job that fails will stop the whole pipeline. Now, there's some situations where people have things that say, look, I know that once a week this fails, the system it's talking to is flaky, it's not critical in my pipeline. So you can exempt certain jobs and you can say, okay, this one's allowed to fail and it's okay. But as a rule, by default, any job that fails will stop the whole pipeline. Because ultimately, unless the user has configured it otherwise, we don't know that that job isn't critical for all the downstream pieces. If that fails because of something that is recoverable, like it's a network, as in the example in the question, it's a network outage, the network comes back, this little retry button, it does what it says in the tin. If that job had a red X by it because it had failed, when the situation recovers, I click the retry button, that job will run, and if that job runs successfully, the rest of the pipeline will carry on regardless. So in most situations, once the cause of an error has been resolved, you simply retry that job and the rest of the pipeline will continue from that point, pick up where it left off.
Yeah, that makes a lot of sense. And would that always be a manual approach to do that, Guy, or could you write something that would monitor for that would automatically click those off if periodically you wanted to recheck or something like that?
Yeah, so you can put automatic retries inside jobs. It's not something that we generally use because if I've tried to ingest data or I've tried to create a new clone inside Snowflake and it's broken, very often it's broken because of something that isn't going to recover. But there are situations, particularly people dealing with remote databases in far-flung parts of the world where network connectivity isn't brilliant, and they do have a significant number of failures where you can say, okay, I'm going to attempt this job up to 5 times. So if it fails, it'll wait a timeout period, then it'll try it again up to a count that you specify. If it fails 5 times in a row after waiting between them, then it's going to say, look, this isn't recovering on its own. Some human has to get involved here to rectify the situation, and then you go to the manual retry process. But yeah, if you've got something that is regularly failing that does usually recover on its own, you can just put retries into the job.
Yeah, a couple of questions on scheduling, Guy. Do you have your own scheduler? Do you
absolutely.
have to use a third party? Can you integrate with third party schedulers?
So we can. So we have a complete northbound API. So essentially anything that I can do through the UI, I can do through an API as well. So, we do see some people doing federated orchestration. They might be using something like Azure DevOps as a top-level enterprise orchestrator. Obviously, Azure DevOps knows nothing about data, so it isn't a great choice for a DataOps platform. The DataOps platform might be the data domain orchestrator. You might have another orchestrator for the network domain, another one for the security domain, and then you have this top-level enterprise orchestrator that sits across all of them. So absolutely, you can use those for scheduling, and then you can kick off jobs in the DataOps pipeline. I'd say the majority of our customers still just schedule jobs in here directly. So this is an example in one of our demo projects. It's pretty straightforward. I say when I want to run, what time zone I want to run it in, which branch I want to run it against. Typically, I'm doing pretty regular runs of my master and QA branches. Maybe I'm running my dev branch slightly less frequently. I can put particular variables in here if I want to personalize the way that pipeline runs. But yeah, we can do pretty much anything in terms of scheduling. Time zones are becoming increasingly important, as particularly for sort of larger and more distributed organizations, actually being able to specify what time zone something runs in. To make sure that we catch the, for example, when a source systems finish its updates, is actually amazingly useful.
Okay, I've got another one here, which is an interesting one. It goes back to that testing and test-driven development, and it's how about mock data or data virtualization to support testing pipelines on data that is normally sensitive or unavailable reliably? Does DataOps have a solution to address that?
Yeah, so we, as a general rule, people want to test on data that is as close as possible to production, because that's the best way. If I'm building a new feature, I mean, Sam's example of calculating some tax, the best way to calculate tax is to actually look at real data and make sure it works for that. However, there are situations where that data is too sensitive, or there are situations where I've got some very, very specific test cases I want to run, that require effectively mock data. So there's two ways to do that. And in fact, I kind of showed it in the scheduler. One of the things I can do is configure my pipeline. For example, I could say, do a run of the dev pipeline where mock equals true, and that will cause the pipeline, rather than to do it zero copy clone, it will say, okay, I'm going to repoint and look at a different set of source data, a reference set of source data. You can also set those pipelines up effectively to be what we call like a golden master pipeline. So if I've got a set of reusable functions, let's say I've written a function that calculates tax, and I'm using that function in 20 different projects all over DataOps, what I actually might want is say, well, I want to centralize that logic into a master project. And inside that master project, I'm not using real data. This is my, this is almost back to the more software classical CI/CD. I've got a central library of functions, and I want to test those central library of functions against reference data, and then I want to inherit those functions once they're tested into lots of different DataOps projects. So when we're working with very large organizations, they might have 15 or 20 different business units who all want to standardize the way they calculate tax. And so they will have a central project for all their central functions, and those projects will typically use mock data to test their pipelines as opposed to real data.
One question from me, I saw the question earlier, I don't see it now, and maybe you answered this along the way a little bit. Does the tool support data virtualization? And
yeah, so it comes back to orchestrating anything in the data ecosystem. So there is no native functionality in DataOps for data virtualization, because it's not what we do. But if there is a requirement for data virtualization, as there is in a significant number of organizations, then absolutely you would simply orchestrate that as a stage in your DataOps pipeline. And potentially both parts of it. Creating new virtualized data sets in one set of pipelines, and then reusing those virtualized data sets in different pipelines.
I've got one that's come in here on Gallium, which is to do with the compression. Does Gallium compress over a time period? E.g., for industrial IoT, I've taken min, max, average from all points in every quarter hour. So how Gallium deal with that?
So I'm laughing because I've spent 20 years dealing with large amounts of time series data, and the min, max, average from all the points in the time period was one of the techniques that I used to try and reduce the data set. So, that's a very early genesis of the thought process that led to the Gallium technology. Ultimately, Gallium works over a window of data points. So you can imagine it as a time period. Gallium works in a batch or micro batch mode. So the most standard way of using Gallium on top of something like Snowflake would be, I'll load my data into Snowflake as normal, and then periodically, maybe once a day, once every 6 hours, something like that, I'll grab that most recent data, I will classify it through Gallium, and then I'll store it in a different set of tables, typically clustered differently, so we can cluster by accuracy, and then I'll just join that whole thing together with a view. So the most recent data is coming in raw, essentially sitting at 100% accuracy, and as that data hits a certain age, I'll gather it up into a bucket, 6 hours, 12 hours, whatever, classify it through Gallium, and then store that into a different set of long-term historical tables where it's organized by level of accuracy.
Another question, how do you use, does this work with Azure Data Factory?
Yep, we have standard runners for both Azure and AWS. So anything that you can do in Azure or AWS, you can orchestrate natively from a DataOps pipeline, including Azure Data Factory. Okay,
here's an interesting one. Can you use this tool to create and manage branches for Matillion versus the native Git integration that it uses? So, can you manage Matillion from and other tools like this, and how closely does it integrate with some of the Git capabilities inside there?
Yeah, so there's quite a bit to that question. Matillion has a fantastic API that allows a lot of things to be done. There are really two ways of considering a tool like Matillion. One way is say, okay, well, the code for what Matillion is doing sits inside Matillion, and you just call it on the latest version, and you version that externally. That's typically where most people start. That's kind of the crawl, walk, run. But very quickly people say, well, look, I want to revision everything together. I want to revision what I'm doing in Matillion, or what I'm having Matillion do, versus what I'm doing in Snowflake, my Snowflake orchestration, my modeling and transformation, my testing. I want to version all of this together. I want to branch it all together. I want to promote it all together. And at that point, yes, you would either by integrating with Matillion's backend, or by effectively dynamically updating Matillion jobs as part of the pipeline, which is the most common way of doing it. But yeah, you would effectively version everything in the DataOps platform, and then make sure that at any point in time, you've updated Matillion to use not necessarily the latest version, but the version of that configuration in the branch that you're in. So your DataOps branch becomes, or DataOps becomes the source of truth, and essentially you're pushing out into Matillion at runtime.
Well, folks, we've come to the end of our hour. I know, Justin, you want to push up our last slide?
Yeah, so Kai, I don't know if you can just go to the last couple of slides. I think just three things I would say to everyone. Please feel free to back one, just join up and get the blog series and find out a little bit more about how we're dealing with the declarative versus imperative. It's great reading this. You can join up to True Data Ops, which is the Get the Dummies book, and feel free, anyone. We're in Partner Connect on Snowflake, so you can hop into Partner Connect if you've already got your own Snowflake and just click the button and deploy us in there. So we'll be delighted to support you. That's it, Wayne.
Great. And I want to thank Justin, Guy, and Sam for demoing DataOps.live and giving our audience a preview of what you can obtain in that tool. I want to thank all of you for listening in. And if you have any questions, don't hesitate to contact Eckerson Group or DataOps.live. Thank you all very much.
Thanks, Wayne.
Thanks, Wayne.